All right, ladies and gentlemen, we are going to do one of my favorite topics, which is solving logarithmic equations. And we've actually already done a lot of this, but we did it with natural logs. And so let's go ahead and start this problem. What we need to do right now is basically get our equation in terms of just plain old log base 2. So there's a couple things we have to deal with. We have to deal with the 1/2 and we have to deal with the 3. And so what we're going to do first is deal with the 1/2, and we have to multiply by 2 over 1 on both sides to get rid of that. So obviously the 2 and the 2 cancel, the 1 and the 1 cancel, and I'm left with a log base 2 of x plus 4 quantity cubed. And 15 times 2, that's going to give us a 30. All right, next thing we're going to do is deal with this exponent. We're going to bring our 3 down in front. So that's going to give us a 3 log base 2, sorry, I'm choking, of x plus 4 equals 30. Now I'm going to divide by 3 on both sides. The 3's cancel, and I get a log base 2 of x plus 4 equals 10. All right, now is kind of the point where I remind you that logs and exponents are inverses. So what we do in this case is something you may have never seen before, but we're going to take 2 to the power of both sides. So this reads as 2 to the 10th power, and this is 2 to the log base 2 of x plus 4. And you should recall from a couple of videos ago that if I have 2 raised to the log base 2, if these two numbers match right here, what we can do is we can cancel them out, meaning I can go cancel. And so I'm just going to drop down my x plus 4, and then I pick up my calculator and I do 2 to the power of 10, and I get 1024. All right, so now I have x plus 4 is equal to 1024. I subtract 4 from both sides. The 4 minus 4 cancels, and I have my final answer of 1020. And you certainly could go back and check your work if you'd like. You got to admit those are kind of fun. All right, let's go ahead and deal with example 2. Again, there's 2 things we want to get rid of, the 5 and the 4. And I'm going to just show you a different method than the last time. It's pretty much the same thing, but know that you can take this 4 and bring it down right here. So you have 4 times 5, right? So this becomes a 4 times a 5, and that disappears, which becomes a 20 log base 3 of x minus 2. Okay, so if you're kind of confused what I just did, I basically just got rid of this 4 by bringing it down in front. And I know that 4 times 5 is 20. So you can certainly do this any way you'd like, but that is one way you can do it. Next up here is, whoa, where'd it go? Oh, I think I'm on the wrong slide. Okay, so now I'm going to divide by 20. Okay, the 20s cancel. I'm left with a log base 3 of x minus 2. Well, 40 divided by 20 is just plain old 2. Okay, now what number are we going to raise to both sides? Well, this has a base of 3, so I need to choose 3. I'm going to go 3 to the power of this and 3 to the power of that. So when I choose 3, I can cancel this, and I'm just left with x minus 2. And 3 squared, I know it looks kind of funny, but it is saying 3 squared, that's 9. Last step is to add 2 to both sides, and I get x equals 11. There you go. All right, this next one here, I'm going to go back to the first method, although you certainly could take that 3 and multiply it by 2, and that's 6. But let's go back to our old method of dividing by 2 first. The 2's cancel. I'm left with a log base 5 of 2x plus 3 cubed. And we know that 12 divided by 2 is 6. Next thing is I'm going to bring this 3 down in front. And so that 3 disappears. Divide by 3. I get a log base 5 of 2x plus 3. Well, 6 divided by 3 is 2. All right, at this stage you say, what log base do I have? And you have a log base of 5. So I'm going to take 5 raised to the power of both sides. These cancel, and I'm left with a 2x plus 3. And I know that 5 squared is 25. That's 5 times 5. All right, so rewriting this, 2x plus 3 equals 25. Subtract 3 from both sides. 2x is equal to 22. Divide by 2, x is 11. All right, I hope those 3 examples really helped you and you can tackle the video problem. Thanks for watching, y'all.